Okay, so members, welcome. Today we are going to see how do we use properties or laws of logarithms to handle some proofs, but please don't forget to subscribe to the channel. Now, to start with, I have this, but I'm going to start with a simple exercise here. How do you know? Look at this one. If we have log of 4 base 2, you ask yourself, what should I raise the 2 to get 4? Is that I need to raise just the 2 to get 4. So the answer there is 2. The other one is, what should I, if I have this, you ask yourself, there are two sort of reasons, what should I raise the 2 to get 8? Is that I need to put here 3 to get 8. So what the power I need to put on that 2 becomes the answer. If you have, say, log 110, what should I raise to this 10, to this base to get 100? So that you need to power this 2, and 10 power 2, you get 100. So the answer there becomes 2. So I'm going to use this idea when we are answering this question. Maybe lastly, you ask, what should I raise to a 2? Maybe if you have this, you see, what should I raise to a 2? I mean to a 4 to get 2. So if this is a 4, you start you need it, you start this one, you just need a half. Because the square root of 4, you get 2. So the answer there is a half. So we are going to see how do we use that property here. Now, first of all, x of x to base 8 is that we need to change the base in our proof. What are we going to use? We use the property that log the same as log of a base c, then b base c. If you want to introduce a new base. So here I want to introduce a new base. I'm saying base 4. So this will be now the same as x to base 4 over log of 8 to base 4. Then you start this one, and this we can use the thing we have been using there. What should I raise to 4 to get 8? So now I have a 4. I need to get 8. So it's that, first of all, I know this 4 is the same as 2 power 2. I want to get an 8. So I want to remove first of all this power. So meaning I will introduce a half. So if I introduce a half, I'll be having 2 remaining. So what should I raise the 2 to get that 8? You start here up, I will need a 3. So meaning, you see that when I cancel this, I'll be having 2 power 3, which is 8. So the idea is very simple. So what should I raise the 4 to get 8? Is that this one we have seen that. It's going to be now over, so it's that we need 3 over 2. 3 over 2. And if you get the reciprocal of this, r x8, you see the reciprocal of this, 2 over 3, then log x4. And you are done with that proof. It is. Then there is an part there. How do we have that part? They are giving us this. Find this if this is equal to this. So they are giving us that where there is x, they are putting a 6. You see. So where I'm having x, I'm going to put a 6. So this will be now here I also put a 6, 4. Now they are giving me 3 base 4. So here I have 6 base 4. But I'm seeing this 6 contains a 3. This 6 contains a 3 as 2 over 3. Then log base 4. Then this is the same as 3 times 2. So now, then I use the properties of logarithms. If I'm multiplying it, now this will be 2 over 3. Then I expand this one to log 3, 4, then plus log 2, 4. This will be now into, now they gave us this from the question. It's 0.7925, then plus. What should I raise it to a 4 to get a 2? You have seen that that one is as simple as getting your half. So putting this on the calculator, you have now 0.7. So here the answer I get, the whole answer is 0.1 7, I'm giving this 4 decimal places. If I come down to this, you see that now there I'm having log of x to base 2 equal to this. They want to show that this is this, and this find x and y in, they give you this and this. So here, if they want me to prove this, meaning before I apply something here, they are multiplying, meaning they multiply somewhere. Meaning, before you multiply, logarithm should be to the same base. So here, I introduce also a new base using this property here. So instead I need base 2, then I'm going to introduce base 2. Now log y base 2 over using this property here. The whole of this is equaling to a 4. Now you see this one. What should I raise to get 4? And that one we have seen. It's very easy. Then plus 2. Then log y2 over. What should I raise to get 4? That's a 2 equaling to 4. So this and this cancel. And you see that same base, we can easily multiply these two. Then we have apply another property which says this one, it says if we have log, then it's the same as a b power c. Then this will be the same as xy equal to the base power 4, and such your xy is equal to 16. So we are done with that proof. Now they are telling us that hence solve. So now this base, this logarithm is having no base. And we said if a logarithm is not having any base, it means that it's base 10. So now from there, log x plus y equal to 1, now base 10. Still we apply this property, meaning that our x plus y will be 10 power 1. That our x plus y is equal to 10. So now we have two equations already. So we have this and we have this. So from here, if you make x the subject, that your x is going to be 10 minus y. So if I put it now from here, my x is equal to 16. If I put what x is that I have into y equal to 16. Open brackets. Taking everything that aside, you have y squared minus 10y, then plus 16 equal to 0. Two numbers I multiply, I get 16. When I add, I get, I think that is y minus 8, then y minus 2 equal to 0. So either my y is 8 or my y is 2. So when y is 8, so that here my x will be at 2 when I put here y. And when my y is 2, my x here will be 8. So any pair I take, it will work for you there. So if I choose one pair, therefore my x is, if I take 2, so when I put here 2, I have 1. If I put here 8, if I put here y as 8, you say I'll be having 2 over 3, which will give me 4. So x is equal to 2, and then my y will be 8. So you can test for this, you'll be having 3, and take this as 2, you'll be having, it's also the same. So, and also your x can be 8, and when y is 2. Those are the answers. Now if I come to this, here we are going to use this property, just that log of a base equal to c is the same as a equal to b base c. So if I have now there equal to b, it means that from here my x will be 3 power p. I call this equation 1. If I come to this, so that this will be the same as x equal to 18 power cube. But now we see this one is my equation 2, so that x is equal to x, meaning that now my 3 power p is equal to 18 power cube. Now we start in my proof, they introduced a new base, which is base 6. So I'm going to reduce log to base 6 both sides. I'll be adding now log 3 power p base 6 equaling to log 18 power cube 6. We're using properties of logarithm. This one will be lowered to get p 36 equaling to q now into log 6. But we are seeing in this we know we need 3. So this is the same as there are many. It's the same as 3 times 6, we shall get 18 back. So if we expand that, we have p equaling to q. Now this will be log 36, then plus log 6 to base 6. So this, if we start this one, log this the same as this would be 1. So we have p equaling to, if I multiply there, I have now, okay, if I multiply, let me give you this, then plus a 1. So if you multiply there, we have p log 3, 6. If I multiply here, then plus q. Take this side, so that this will be common. You have p minus q into log equaling to q. Divide it that side, so that now be q over p minus q. It is. So members, that's how you can handle those proofs. Don't forget to subscribe to the channel. I wish you the best.